Hello everyone, welcome back to my channel. And today I'm really excited about today's recording. Firstly, because we are beginning our phase 4 of 100 days of DevOps, and today is day 50. So which means we've gone halfway in our journey, and it's really been one wonderful and amazing ride so far getting up to this day. We've covered so much, and I believe that watching this video, you would have been able to gain one or two things to add to your knowledge, and some things you would have been able to familiarize yourself and even gotten better with a lot of concept. Then, secondly, because this phase 4 is what we are going to be covering in this phase 4 is something that it's one of my favorite parts of tech, not just in DevOps tech as a whole, because I really enjoy working with Azure. I, for one, I'm an Azure administrator, an Azure developer, an Azure solution architect, and an Azure DevOps engineer. And yes, I'm certified in all of that. So it's really exciting, and I really look forward to um, trying my best to give all in this particular phase, because it is one of the important phases in the whole DevOps process. So we are going to look at in this phase over the couple of days, or maybe it might be a week or more than that. We are going to cover Azure, the essentials. We're not going to look at Azure in a cloud engineering perspective. We'll look at Azure in a DevOps engineering perspective. What I mean by that is that we won't be covering Azure end to end. We'll just cover the things that we need for DevOps, because this is a DevOps 100 days roadmap, not a cloud roadmap. So, yes, we'll just cover some one or two areas of Azure that are essential to our day-to-day DevOps activities, like cover normal resource groups, subnets, AKS, and the likes. But before we go into that, there are some okay, before we go into that, if you're seeing my video for the first time, we are trying to cover DevOps in 100 days, DevOps fundamentals, DevOps essentials. Basically, we are drafting, or we've mapped out a roadmap that can help maybe beginners or people that just know little about DevOps and they're looking for a proper guide or a proper roadmap to, make their journey easier. So this is what these 100 days have come to achieve. So, and so far we've covered a lot of things. We've covered essentials that are really, really fundamental to our learning process. So now we are already entering the intermediate part of our journey. We had the essentials, we covered Linux, we covered networking, we covered, shell scripting. I think we entered containerization and then CI/CD and all of that. So this is like the intermediate part of our journey where we start covering things like cloud and all of that. And I'm excited to actually see how this goes. But before we start going into Azure and all of that, there's some basic concept like we always do. We always try to make sure that we are familiarized with the concepts before we start, looking at the tools. Just the way we did in our phase 3 where we covered CI/CD, and we're able to establish that the concept is the same across all CI/CD tools, and then we picked two CI tools to demonstrate and also to show us that in truth the concepts are actually the same. We run exactly the same commands in both Jenkins and GitHub Actions, and if you have not seen that video, I believe that you have to go back, see those videos, see the previous videos before you come to this one, because the way we have done it, every video or every recording you see is a layer above the previous one. So if you say you want to skip a part of the video, you might be missing out on some things, and then some concepts will not be um well known to you. Yes. So same thing that comes to cloud. So we're going to cover cloud essentials as a whole. And before we now start going into um Azure itself, because there are so many cloud providers. There's Azure, there's AWS, there's GCP, there's DigitalOcean, they just name it, right? So sorry. We'll go straight into the business of today. So we are going to look at one, two, three, four, five, six. So I'm just going to look at six concepts or six topics under cloud essential, and I'll try to be as explanatory and as practical as possible. No, we're not going into any virtual machine. We're not going into any website, just pure, concept or understanding. And yes, so far we have been using our hypervisor, our VM on the hypervisor on our local PC. So going forward, we will not be using that again. We are Everything that we are going to do from here on going forward will be done on the cloud. Yes, so we have moved from on our local PC. We are moving from our local PC to the cloud. So whatever we are going to do from today going forward till the very end of these 100 days, we are going to do it with cloud. Yes. So, first thing is, what is cloud computing? So, I'm just going to give a little backstory on how cloud computing came about, because cloud computing didn't come into existence until about, say, 15 to 20 years ago. So, what happened before then, right? So, um, before then, we understand what servers means. Yes. So we understand what servers mean. Server is not too different from your computer, right? The difference between your computer and server is like an advanced computer, an advanced PC, right? It has more RAMs, it has more CPUs and all of that. And most times server doesn't have this user interface. It's more of like a CLI thing, right? So I think Windows Server actually has a GUI. But if you're looking at the Linux part of it, Linux is mostly um, CLI. So let me get my shape. So now this is companies want to host their application, and applications are hosted in servers. So before now, what they do is that they will take a server and host an application on that server. When you want to have another application, you host it on another server, and then you have different servers like this, and let's say you have six servers hosting six applications. So this is where everything all started from, right? And all of these servers, they will be put in something called a rack. That's I'm trying to explain how it is done on-prem. So this is how it is done on-prem. So these are servers, and so these are servers that have been placed inside a rack. So yes, and then we have another. Now, so a rack will contain, like, there's a particular number of servers that a rack can actually contain rather. So now when you have several racks in probably a particular room, a particular space, that is what we call a data center. So let's just assume that all these ones I call server, let's just assume that they are racks. So we have six racks that contains different servers, and they are all put in what we call data center, a data center. So now a data center contains, racks of servers and all of that. So now each server houses one application, right? I'm going somewhere. Each server houses one application and all of that. The issue now is that dedicating one server, a single server can have, unlike our traditional PCs, that you can have a PC with you can have a PC with 512 gigabytes SSD. That's the ROM. That's the RAM. And then you have maybe 16 gigabytes, 16 gigabyte RAM. This is like a basic or a normal PC spec, right? But in a server, like I said, server is like a supercomputer. In a server, maybe um you can have maybe like 200 terabytes of RAM of ROM, and you can have maybe like let's say these are just hypothetical figures. 100 GB, 100 GB, 1000 GB RAM. You can have maybe like you can have like 1000 CPU. So imagine dedicating this resource to just one application. It's a waste of resources. It's a waste of resources. So now there's always innovation. Technology is always about innovation. So I believe some set of people came and then they said, okay, instead of dedicating one server to one application, let's make it better. How can we make it better? Then the issue of virtualization. So virtualization came into play where I'm going to all these terms, I'm just going to give like an explanation. I might not, take them one after the other, but just try and go with me. I'll just find a way to wrap everything up. So now the issue of virtualization came into play where we had things like if you've I think I've done this illustration before. I think maybe when I was doing Linux introduction or when I was doing cloud computing introduction, then you have what we call a hypervisor, right? So by now hypervisor should not be a new thing to you again. Hypervisor and hypervisor. So what does a hypervisor do? Hypervisor just helps you to um, you run several operating systems on a server, right? So you have now instead of having just one application on a server, you now install instead of the hypervisor the on a single server, and then you now have several applications on one server. So we moved from having one application per server to several applications per server. Now, this reduces resource wastage. So now the resources in a server are better allocated into different because you can call it virtual machines, right? You can call it virtual machines. So you have virtual machines on a particular server that runs the application, virtual machines on a server that runs application. So we started from having a single application on the server. Now we have a hypervisor that you can install virtual machines that houses the application, right? So now this was working fine and all of that. It's looking very okay and things are going fine until a big challenge comes. The challenge now is that to purchase a server is not a small money. Servers are very expensive to purchase. So now what happens to um, small and medium scale enterprises that needs to host applications and all of that and don't have the funds to actually um, buy a server. So this setup is intensive, right? Capital intensive. So um there's something called capex, and opex. So in a traditional way, right? This is capital intensive. It is focused on capex, and this on-prem, right, can also be called a private cloud, right? So this on-prem can also be called a private cloud. So now this is the first thing is that it is capital intensive. The second thing is that if there's any power outage in this data center, then your both your servers, your application, everything goes down, and then you are losing money per second. That's two. The third thing is that to get the server is actually expensive. Then the parts of those servers. There might be a cable failure, there might be hardware malfunctions and all of that. So they get to get all these hardware, to get all these, parts replacements are, you know, very, very expensive. You understand? So how then do we make it in a way where, the small scale can also host the applications, can also, do all of these things? That is where computing came into place. So Amazon came and said, okay, instead of you, um, Amazon came and brought AWS. So that's where we have AWS. So now, and they were like, okay, instead of you having your own database and all of that, we would create, I'm sorry, your own data center. We would create data centers all around the globe, right? We'll create data centers all around the globe. All you have to do is make a request. When you make a request to a data center, we'll, to AWS. Now we would link you up with the data center that is closest to your location, and then we'll pick a server in that data center and then create a partition, or in this case, a virtual machine for you. So that is what cloud computing is actually about. Your own, what you see as cloud computing is the company's data center, right? So instead of having your own data center, because I believe some people feel like cloud computing is one magical thing. They wonder, how can you create servers in the cloud and all of that. Basically, what we call cloud computing is just, you don't have your own data center. You are using someone else's data center. You're using someone else's data center. So companies like Amazon came up with AWS, and then Microsoft followed with Azure, and then we have Google also have GCP. So these are the major cloud providers. They are the major cloud providers. So now, that is basically a summary of cloud computing. You are basically working um, with resources that are not on-prem, that are not, you don't have like a physical, you're not working with physical servers, you're not working with physical storage, physical network interface card, you're not doing anything physical. Everything you're doing is on another person's data center, but you just have an interface where you interact with that person's data center. So that is what cloud computing, has. That's like the an overview of cloud computing. It's basically just getting um cloud resources basically over the cloud. When I mean over the cloud, I mean virtually. So that is like the concept of cloud computing. I hope that's as you've been able to gain a thing or two. You've been able to understand what cloud computing really is, right? So we started from having your application given to a server. Then we talked about hypervisors where that host virtual machines. And then you can now host your applications on those virtual machines. And then we talked about the limitations, we talked about the disadvantage of that. And then we now moved to what cloud computing has come to solve. Yes, so cloud computing has come to, mitigate against all of that. So while on-prem focuses on capex, which is capital expenditure, cloud focuses on opex, right? All you have to do on cloud is operations. So cloud focuses on opex, while on-prem data center focuses on capex, right? And that's why they are more capital intensive than cloud. So I don't know if everything I'm saying is making sense. So now let's move to private, public, and hybrid cloud. I've already explained private cloud, right? Private can also be called on-prem, which is your on-prem data. That's on-prem data center. Yes, so there are a lot of banks that still have their data centers on-prem. So that is private cloud. It means that you are in control of everything, from your servers to your storage to your switch, and all of that. That is private cloud. Now, public cloud are what AWS, Azure, this GCP has provided or has come to provide. So those using Azure, those using AWS, those using GCP, DigitalOcean and all of that, we are using public cloud. So Azure is a public cloud provider. AWS is a public cloud provider. GCP is a public cloud provider. So now we now talk about hybrid cloud. What does hybrid cloud actually mean? Basically, from the word, hybrid cloud integrates both private and public cloud. But you'd also ask yourself, okay, why would somebody want to, you know, why would people want to, or companies want to use um, hybrid cloud? Majorly, the reason one of the biggest reason why people use hybrid cloud is for security purpose. When I mean security purpose, in a company, some organizations like banks, like financial organizations, there are some sensitive information that you cannot afford to, put in the cloud, that you cannot afford to make public. They have to be private with you. So sometimes a company can, have their VMs, their virtual machines and everything on the cloud, while they'll have maybe like a database on-prem. They might just have a database server that is sitting on premise. So they are using both the cloud platforms for things like virtual machines and all of that. And then you have a server that is on-prem that holds your database. So that way you are incorporating both the private cloud, which is maybe Azure, GCP, AWS, and then you have your public on-prem server that houses your sensitive or critical information. There might be some government policies that do not allow such companies to actually use migrate their information to the cloud. So that is why most people would use hybrid cloud, and a lot of people actually use hybrid cloud, especially top organizations that has like banks, like financial organizations. I think oil and gas also. Those sectors, they use more of hybrid cloud. Yes, they use more of hybrid cloud. So basically, private cloud is your servers, your data center, that is, physical data center is the private cloud, also called on-prem. Public cloud is using Azure, AWS, GCP, DigitalOcean, and all of that, using the services that they are provided. On their own end, it's an on-prem for them. But from our own end, that is from the end users, perspective, it's a public cloud. They have made those things public to you, where you can just request for a virtual machine. They give you, you request for a storage. They give you. You don't have to. You don't bother yourself about, the physical parts of the virtual machine or the physical part of the storage and all of that. While hybrid cloud, incorporates both the private and the public cloud. There's also one which is called multi-cloud. There's called multi-cloud. Multi-cloud, from the name, multi-cloud is when you use Azure and AWS. So you are using two cloud platforms at the same time. There are companies that have some stuff hosted on AWS, and then they have some other things, hosted on Azure and all of that. So I believe I've been able to explain what cloud computing means. I also believe I've been able to explain what the difference between private, public, and hybrid cloud means. And I think I've also covered virtualization and virtual machines. So I will talk about IaaS, SaaS, and PaaS and SaaS. So what does IaaS, PaaS, and SaaS means? Basically, IaaS is, okay, let me go here. So this is IaaS, SaaS, and PaaS. So IaaS means infrastructure, infrastructure as a service. PaaS, PaaS means platform as a service. Why SaaS means software as a service. So these are, when it comes to cloud, these are the three services that your cloud provider, offers to you. They offer infrastructure as a service, they offer platform as a service, and they offer software as a service. All services in cloud revolve or fall into these three categories: infrastructure as a service, platform as a service, software as a service. So now, what is infrastructure as a service? So basically, infrastructure as a service, yeah, the cloud provider provides you with the basic infrastructure, and that is all they do. They just give you the infrastructure. A typical example of infrastructure as a service is your virtual machine. So the cloud provider will just give you your virtual machine. That is all. They are not, they are not installing anything. They are not setting up anything. They are not, configuring anything for you. You are responsible for configuring some all of that. So an example of this, just like I said, is your your virtual machine. So a virtual machine is an infrastructure as a service. In this type of service, the cloud provider provides you with just the infrastructure. The setup, the configuration, the installation, it is done by you and you alone. That is infrastructure as a service. So from the diagram that you're seeing under, the blue part, shows you the part you manage. The red part shows you the part that the service provider manage. You can see that on site, that is on-prem, you manage everything down from the application, from the application layer down to the networking layer. You are responsible for everything, and this is something that can be a bit overwhelming and a bit tasking if you don't have enough funds or enough experience for all of that. While for infrastructure as a service, the service provider provides you with the networking, the storage, the servers, the virtualization. As I said, they provide you with the infrastructure while you're responsible for setting up the operating system. You choose which operating system you want. If it is Linux, if it is Windows, if it is Mac OS, you choose the middleware, you choose the runtime, you choose the data that will be on the the infrastructure, and then the application that will run on the infrastructure. You are basically responsible for everything. So that is infrastructure as a service. Now for platform as a service, basically they give you there's a little bit more, the service provider caters for a little more than just the infrastructure. So what they do is that they create a platform already. Like for example, say example of of PaaS is a web server. So there's there's a service in Azure called Azure App Service or Azure Web App, where they've given you everything you need. Apart from the infrastructure, they've also configured the operating system, configured the runtime, and all of that. The only thing you are doing is you are just running your application on it. Let's say, for example, now you want to host. Okay, I'll give you a typical example. You want to configure you want to host. Which example do I give now? Okay, you want to host a website, right? You want to host a website. Let's say a portfolio website, and you're trying to choose. Okay, should I use infrastructure as a service? Should I use platform as a service? So when you want to host it in an infrastructure as a service perspective, you are only given the VM. You first of all, you have to choose your operating system. Do you want to host your website using on a Windows operating system or on a Linux operating system? Apart from that, you need to configure that server to be a web server. So you are manually configuring the server, the VM rather, or the server, whatever you want to call it. Okay. Let me stick with VM in this scenario. So now you are given a VM. You have to configure that VM to act as a web server, so you can host, because for you to host your website, obviously websites are hosted on web servers. So applications are hosted on app servers. So you have to configure your virtual machine by yourself to be a web server, and then before you can now host your website. Now, in a past perspective, platform as a service, you don't have to configure anything. They've already given you, they've not just given you, they've gone beyond the virtual machine, the infrastructure level, and they've configured that VM to be a web server. So they are giving you a web server directly where you don't have to configure. All you need to do is just slot in your code or slot in your data, and then everything is up. So we are going to look at all of that during the course of um our subsequent videos. So for the platform as a service, you are only responsible for your application and then the data. Every other thing, runtime, middleware, operating system, virtualization, server storage, networking is provided by the service provider. So for the software as a service, basically the service provider has done everything for you. Like you're literally not doing anything. You're not setting up anything. You're not putting any data. You're not, all you need to do is just basically sign up. Example of software as a service. Your Gmail. Your Gmail is a software as a service. The only thing you do on Gmail is sign up. That's basically what you do. You sign up. You're not setting up. You don't even know the server that is hosting the Gmail in the first place. Your Microsoft 365 is an example of a software as a service. So these are options that you can actually choose from. Like I said, everything about cloud falls under these three categories. It's either you're using an infrastructure as a service, or you're using a platform as a service, or you're using a software as a service. So I hope that I've been able to do justice to IaaS, PaaS, and SaaS. So what else do we need to talk about? Okay, finally we're going to talk about regions and availability zones. I'll take those two together. So for regions and availability zone, let me create a blank space. I'm just going to do an illustration also so we can actually get it. Now, let's just assume that this circle is a map of a world map, right? This is a world map. So now, what is a region? Let's take out from the world map. Let's take out. Let's say let me get another shape. Let's say this is US, right? Let's say this is US. US is a country, right? So now, when I'll bring out US, let's bring out US here. In US, we have East US, we have West US. Now, let's divide this into two. Let me divide this into two. Um, so we have East US on the right and West US on the left. This East US is a region. What I mean by a region is region contains is a region is where you have data centers. You can have data center in a region. So the East US has one region, the West US has another region. So in US we have different regions in US, but basically I'll just say we have East US and we have West US region. Under East US, I think we still have East US one and East US two. Then there's Central US and all of that. So in America alone, you have like different regions. Different regions contains the physical data center. Regions contains physical data center. That is one thing you need to know. And there are several regions around the world. There is there's region in maybe there's region in Africa, there's region in Brazil, there's region in China, there's region in India, regardless of the location. So that's why I said whenever you make a request to Azure, it gives you maybe say you want to get a VM. It gives you a VM with in the region closest to you. So if you're in United States and you make a request for a virtual machine, except if you state that you want that virtual machine to be created in maybe India, or maybe you want it to be created in Brazil, and I don't think it makes sense because one, you will have high latency. You have high latency. That means latency means the time taken for data to travel from one location to another. So you have high latency, and we don't want high latency when we are dealing with things. We want the latency to be as low as possible. So to mitigate against high latency, Azure has gone, or cloud providers has gone to create regions, different regions that contains different data centers, and then handles resources or handles requests by customers. So just get this and be clear with it. Regions are locations that contains data centers. That's where the cloud providers has put data centers in around the world. Yes. So every 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 location has a region peer. There's something called a region peer, where um for example, East US and West US are region peer. That means for redundancy or for fault tolerance, basically, so that once one region goes down, you wouldn't lose your data, or you wouldn't lose your information of what you are doing, or your business would not go down. So if one region goes down, you can always fall into the second region, and it is very, very rare for a region to actually go down. Why did I say it is rare? That is where availability zone comes into play. So in a region, there's always availability zones. Availability zones are the data centers in that region. So availability zones are the data centers in that region. I think a region has about 2 to 3 availability zones. Availability zone are like the main data center. And like I said, a region is contains the data centers. So now the data centers itself are called availability zone. So most times when you deploy to a region, your your data or your information is not just stored in one region, except if you decide that you just want to have it in one availability zone. But if you are using total availability zone in a region, what is in data center one will be in data center two, will be in data center three, and they are usually not around the same location in that region. They're usually far apart. So even if one data center goes down in a region, you still have your information or your data in other regions. And that is one of the advantages that cloud has. You hardly have a downtime. Most times, most cloud providers will offer you an SLA of 95%, 99.9%. Some even offer 99.95%. So because there's enough redundancy for you, right? So whatever is in availability zone one is in two and is in three. So since they are not in the same location in that region, it is almost impossible for all three availability zones in a region to go down. Now, I didn't say it is impossible. I didn't say it is never impossible. I said it is almost. I think there's a time of recent we had an issue with AWS had a power outage in a particular region. Then I think before you know it, I think Azure also had that. But that is once in a blue moon thing. So it is almost impossible for the entire availability zones in a region, for an entire region to go down, because the availability zones in that region are not around the same location. They are sparsely separated. They are far apart. Do you understand? And then if you are using the total availability zones in that region, what is in availability zone one is in two and is in three. So if you are taking out the buzzword availability zone and all of that, it's just basically data center. So I can as well replace availability zone with data center. So you have three data centers in a region that houses your data, that houses your information, and all of that. So I believe um, I've been able to introduce us to cloud computing and some terminology. These are actually not all. And during the course of the videos, we'll see new things, we'll be introduced to new concepts, we'll be introduced to new topics, and we'll see how it goes from here. So this is an overview of cloud computing. I believe you must have gained one or two. From tomorrow, then we'll streamline into Azure itself, and then we'll start looking at Azure We are going to create our Azure account. I'll show you how to create an Azure account. We'll look at the Azure interface, and we'll learn in some concepts that are peculiar to Azure, right? And I'm going to also be telling you the reason why I prefer Azure to other cloud, providers. So if you've gained a thing or two from this video, and if you've enjoyed this video, please do well to like the video so that it will boost the algorithm, and then YouTube can show it to people that are actually interested. Then, if you are yet to subscribe to my channel at this point, please do well to subscribe to the channel. Most importantly, turn on your notification bell so when I post the next video, you can get it as soon as possible so that you can also follow along, and you can also add to your knowledge. So I'll see you again tomorrow. Enjoy the rest of your day. Cheers.